Find second largest element in Python list. This is one of the most asked Python interview question. This sounds easy, right? But interviewer can trick you in this question to test your Python efficiency. Here in this video, we are going to solve this in three different ways. First, easy simple way using sorted method. The second one is going to be Pythonic one-liner. And the last one we're going to do in the interview way. Let's dive in.
Let's begin with the naive approach or sorting approach, and that is called also the beginner approach. We will first of all sort the list to small to large or ascending order, and then we will access the -2 index or second last index or second last element in the list, and that's going to be our second largest element in the list, and that takes the time complexity of big OF and log n. Let's begin with that and see what value we are extracting and how we are approaching. To begin with, let's define the list of numbers, where I have defined a couple of numbers in the list that call list nums, and this is going to be the test that we will try to find out the second largest number in this list with the function that we want to define. Let's begin with defining a function. I will say def get second largest using sorting technique. I'll just name it in that way, and then I'll pass on any list parameter. Now we will check one condition. We'll check if length of the list one or the list value that we want to check is less than 2, then I will return none. The reason is if it is less than 2, then there is no second largest value in the list or second largest element, then I will return none. If it is 2 or more than 2, then I have opportunity to find out the second largest element. The next thing immediately is that I want to sort the list, that list parameter value, to be in the ascending order. I will say sorted list equals, I will call the function called sorted in Python that will sort the value into ascending order. And now I will pass on the list that I have. It is sorted. Now small value comes first and largest value comes at the last. Now all I have to do is return sorted list, and I will call the -2 index value or second largest value in the list. -2, -1 is the last element in the sorted list that becomes the largest value, and -2 is the second largest element or second last element in the list that becomes the second largest value. And that is all. So we have defined the function that called get second largest sort. I will pass on the list parameter, and I will return at the result, I will return the second last element in the list. Let's check it out. So I have get second largest sort, and I will pass on the list nums that I have defined above and see what value I'm going to get. Here 24. So look at this, maximum value here is 54 and the second largest is 24. After that I have a 22 and 21 and so on. So this function is actually working and is giving us the second largest element in the list. Next approach here is gonna be Pythonic approach and handling duplicates. So we'll check if our list contains duplicate value or not. If that's the case, then we will remove the duplicates first, and then we will remove the maximum value, and then the second maximum value becomes the second largest value in the list. So that's what we are approaching here. First of all, convert the list to set that removes the duplicate, and then remove the maximum value, and the new maximum becomes the second largest in the original list, and that takes the time complexity of big O of n. Now let's define the function. So I'll begin with def. I will say get second largest value, and I will add the name here, simply saying duplicate, and I will pass on the list parameter, and then the immediate next thing becomes is converting list into the set in order to remove any duplicate value. I will say list to set equals, then set, and I will pass on the list parameter, and that will basically remove any duplicate value and only will keep the unique elements of that original list into the list to set. Now we got the new set with name list to set. On that list to set, what I will do is I will check if the number of element in the list to set, so list to set, is at least two characters or two elements or not. If that's not the case, then I will simply return none. That means to find out the second largest, I at least need two elements in this list to set. If there are not two elements at least, there is no second largest value. So there is no way to find out the second largest. I will simply return none. And otherwise, then what I will do is on that list to set, I will simply remove the maximum value of the same list to set, maximum value of list to set, and that will remove the maximum value of the set that we have created and also has at least two elements in that set. So I will remove the maximum value. Then once I remove the maximum value, what do you think is gonna be the next maximum value into list to set? That's gonna be the second largest of original list 1, and that's what we are going to return. Now, once we remove the original maximum value, then the second maximum is gonna be the second largest in the original list, and that's how we will return the max of list to set after removing the original max of list to set. And that is our solution. Let's check it out if this solution is working or not. I will say get second largest, and I will say duplicate, and then I will pass on list nums, and there we have got 24. The first approach gave us 24, and the second approach also gave us 24. So now both the approaches are working as expected. The third approach and the interview approach is going to be a single pass. This is the most efficient solution from the complexity of time and space. So this is called greedy approach as well. We'll update the trackers as we see the new numbers. So basically we will have a trackers called largest and the second largest. So these trackers will be updated as we see the new numbers. Let's begin with defining function called def get second largest best. That the best approach will pass on any list that we have on our hand. First of all, we will check if the length of the list 1 is smaller than 2, then return none. Basically, if the length of the list 1 is not at least 2, then there is no second value, so we will simply return none. Now it is time to define empty or negative infinity value for the largest equals float. I will say negative infinity value, and also the second largest to be same as the negative infinity value. It will be simply, we're saying that whatever the smallest value we have, we can do the comparison for the largest and second largest. So even if it is a negative 1 billion 1 trillion, that will still compare that with the second and the largest as well. So we'll begin with, we have a placeholder value to be the negative infinity for both. You could simply say none, but here we're placing much accurate placeholder value. Now it is time to go through each element of the list that we have on our hand. So I'll say for num or any element in list 1, I will then check if that num or the element on our hand is greater than largest. So basically largest is the negative infinity. So if that is greater than largest value, then we will simply say second equals largest. The reason is because now this number, this element is larger than the largest. That being said, the second largest becomes the largest. So because we already got the largest value, which is num here, then in that case second becomes the largest and largest becomes the num. Largest becomes the num because we already see that num was the larger than the largest value. So largest is we have now the new largest, which is num. The next condition we want to check, if num is greater than second, so we can say that we have some placeholder second which is negative infinity for now, and we'll check if that element is greater than second and that element is not the same as the largest value. It's not the largest, but it is greater than the second. Then in that case, what happens is the num becomes the second largest for us, because it is not the largest, and the num is definitely larger than second. In that case, second becomes num because it is not still largest is the large. There is a another value which is the largest. That being said, the second now is the num, the element that we are into. But for some reason we have not found the second, that we have not updated the second with any element. None of these conditions are satisfied. Then in that case, second is still the negative infinity value. There is no update on the second. In that case, we will simply return none because we have not found any update on or any second largest value with these above iterations. At the end, we'll return the second. So if we found the second, either if this condition is fulfilled, then we have found the second value, or if this condition is fulfilled. So basically, if the number is greater than largest, then number becomes the largest and second becomes the largest. Since the num was greater than largest, the second largest becomes the former largest and new largest becomes the number. Now otherwise, if number is greater than second but number is not the largest, in that case second number becomes the second. And if none of these conditions are satisfied, we have not yet found our second largest, then simply we will return none, and at the end we will finally return the second. That's how you can efficiently find out the second largest. That is considered as the best approach from the interview perspective and from the time and space complexity perspective. Let's finally test the function if it is efficiently working or not. So we'll say get second largest best, and we have the variable already defined above, list nums, and I will run that. I still got the 24 to be the second largest because in our list you can see the largest value is 54 and 24 is the second largest. All others are the smaller than these two values.